My machine learning project was getting a Baxter robot to use MNIST data for handwritten digit recognition. I'm going to walk through my notebook now, and then I have videos of my system tracking numbers in real time and a Baxter robot using the system to perform pick and place. So first, what I did was I considered the work done in homework 3, where we used the MNIST data and we used basic one verse all linear lines to separate the data out, and I used that as my number one option for trying this out. Next, I used a hand-coded k-nearest neighbors algorithm, and after that I tried a convolutional neural network using Keras because of the difficulty of coding that from scratch. So first I got the MNIST data. For my k-nearest neighbors, I reshaped it. There was too much data. My algorithm was too slow to deal with all 50,000 numbers, so I reduced it to 5,900 training numbers and 100 testing numbers. Then I transposed the matrices so that they were easier to work with. This is my k-nearest neighbors algorithm. This will take in a new data point, a sample data set, and a number k for the amount of numbers that you want to check closeness to. I then have a predictor that uses the voting system in k-nearest neighbors to see what labels the nearest numbers have, and then I assign the most occurring label to my new data point. And then I check which is the best value of k. So I ran this for k from 1 to 11 because I added 1 there, and it showed that the best results were around 3 and 5. So either of those would have given the best results that were around 74 or 75% accuracy. Then I used a convolutional neural network in Keras, which I uploaded the Keras dataset for because it was in a nice format. I normalized the data, and I used 2 different classifiers, one with RMS prop and one with Atom. So here I explain how to set up one of them. I use 32 filters. I state the kernel size, the input shape, 28 pixels by 28 pixels, and 1 depth because it's grayscale. I use activation ReLU. Then I flatten the data so that it can be fed to the artificial neural network backend. Here I have 128 nodes in my first layer and 50 in my second layer, and then a 10 node output layer using a softmax activation. I have a small explanation of RMS prop and Atom here that was aided by this blog that I linked. And then I have another setup for another classifier to use Atom. And here I have the results of both using test loss and accuracy, and then the validation loss and validation accuracy. Both of them performed very well. And that is my whole notebook. Most of the problems that I had were more with interfacing with ROS, the robot operating system, than using the machine learning. Getting the two to work together was quite difficult. For that reason, I didn't implement Keras in my final project. It was too hard to get Keras to work with ROS. For that reason, I used one of my handwritten approaches. So I tried k-nearest neighbors. However, that was a very slow system, as it has to check each new data point with all of the old data points in the database, which was a little bit too slow for real time. And I ended up including my model from homework 3, which I saved the weights to a CSV file and uploaded that, and used those weights with the cost function to calculate the costs of each number that I saw in the predictions. Another big difficulty that I had was getting my real-time video data to be the same format as MNIST. That required quite a lot of computer vision and pre-processing using OpenCV to get that to work accurately, as it was important that they were the same and weighted in the center of the images. But here is my project working. Enjoy.
good.
If you can reliably identify, I think we're okay. We've proven that we can move the arm correctly. We've proven that we can communicate through the services. Basically, the logic to like decide what to do is the main model. Like we can move the arm anywhere we want. So
Jordan, what's 6 times 5?
should be that.
Good.
Bang on, son.